Well, guys, this is Guruji Online, and today again we will be solving a JEE Advanced question pertaining to wave optics. So let us see what is the question. The question is before you on your screen. I will read out the question for you. A convex lens of focal length 15 centimeter and a concave mirror of focal length 30 centimeter are kept with their optic axis PQ and RS parallel but separated in vertical direction by 0.6 centimeter as shown. So in this question, they have separated the optic axis of lens as well as of mirror by 0.6 centimeter like this. This is the optic axis of lens and this is the optic axis of mirror, correct? Now, what it is saying further, the distance between the lens and mirror is 30 centimeter. So this is 30 centimeter. Oh, sorry, this is 30 centimeter. And an upright object AB of height 1.2 centimeter is placed on the optic axis PQ. So this is the object and which is of the height of 1.2 centimeter. Okay. Now it is placed at 20 centimeter from the lens. So this is placed at 20 centimeter from the lens. If A dash B dash is the image after refraction from the lens and the reflection from the mirror, find the distance of A dash B dash from the pole of the mirror and obtain its magnification. Also locate positions of A dash and B dash with respect to the optic axis RS. RS is the optic axis of mirror. So what we have to do, we have to find out the final image, that is A dash B dash, and how it is located on this optic axis RS, which is the optic axis of mirror. So let us solve this question. This question has come in 2000 in JEE Advanced. Oh, this is the same figure I have made for you to avoid any waste of time. In this figure, you must be seeing all the parameters. AB object is there, then 15 centimeter. This thing focal length of lens is given. Focal length of lens is 15 centimeter, and of course focal length of mirror is given as 30 centimeter, and that is this is the focus of uh, this mirror, and which is 30 centimeter from the mirror. And then there are two optic axes I have made. One is PQ and another is RS, and both are 0.6 centimeter apart. So let us see how the image is going, and that image will act as an object to the mirror, and then you will get a final image. So as we have seen such type of questions, the main formula is 1 by F is equal to 1 by V minus 1 by U. And with this formula, we can find out what is the distance of the image formed by the lens. Here, U is given as minus 20 centimeter and F is 15 centimeter. It is plus because it is the focal length of the convex lens. Correct? So if we put these two things in this formula, then let us see what will come. If we put this thing, then V is going to come 60 centimeter. Now, the image formed by the lens is 60 centimeter, and that too also plus. Then that means it will be on the left side of the lens. Let us draw this image how it is going to form. We will see, suppose this is the ray which is falling parallel to the optic axis on the lens. Of course, this will go through the focus. Focus of the mirror is here. It is 15 centimeter. So it will go like this, and correct. So this is one ray. Another ray we can take from the pole, and this will be coming like this from the pole, and here we will get a image where they are meeting, and this image will be from this optic axis like this. Now it is 60 centimeter from the lens, so naturally this will be 30 centimeter. Correct. So this is the image we have formed through the lens. Now this image will act as an object to the mirror, and let us draw the image where it is going to form. We can take one ray like this. This is parallel. This is parallel. Then of course this will go through the focus, and another ray we can take from the curvature. So 30 centimeter is the focal length of the mirror. The curvature will be somewhere like this here, and let us see if we take from the curvature. So this point is coming like this. Another what we can do is this ray also we can make through the curvature. Then this point can come, and we can join this line like this. So this will be, this is the image you will get, final image. Correct. So this is the portion above RS, and this is the portion below RS, and this is what we have to find out. First of all, let us find the distance of the final image. How we are going to find out? That we can find out from the mirror formula, and mirror formula is like this: 1 upon U plus 1 upon V is equal to 1 upon F, and here U is plus 30 centimeter and F is minus 30 centimeter. So if we put the values here, then what will be there? This will be like this: 1 upon 30 is equal to 1 upon minus 30, and this will give you V as minus 15 centimeter. So naturally it is on the right side of the mirror, and we have correctly drawn because it is coming just between the lens and mirror, and this distance is 15 centimeter. So our figure is correct. Now, let us see the magnification part. Magnification, first of all, suppose this is A dash and this is B dash. Our object is basically that is 1.2 centimeter, and that is length of AB. Now, as far as lens is concerned, our magnification is basically V by U, and that is 60 upon, and this coming as minus 3. So our length of A dash B dash, basically that is the image found by the lens, is 1.2 into minus 3, that is minus 3.6. And here if we see 0.6 is already between the distance between the optic axis. So what is remaining is this will be 3 centimeter, this length, correct. Now let us see what is the mirror magnification. Mirror magnification is minus V upon U, and that will is minus 15 upon 30, and this is basically plus 1 by 2. So here the image formed by the mirror will be of the length. Its object was 3.6 centimeter. 3.6 centimeter. So 3.6 into 1 by 2, and that will become as 1.8 centimeter. Correct? Now, if we see in the question, it has been asked that what is the image with respect to optic axis RS. So in this figure, if you see, this is 3 centimeter and this is becoming half, correct? So if we see the image like this, this is suppose RS. So image is like this, and 3 centimeter, 3 into 1 by 2, this is 1.5. So this distance will be 1.5 centimeter, and here it is 0.6 centimeter. This is 0.6 centimeter, then it will become half, and this will be half, means that will be 0.3. So the complete length of the image is, that is 1.8 centimeter. So this is how you can show with the figures that how the final image found by the mirror is located with respect to RS, and this is what has been asked in the question. Correct? So this is the complete answer of the question. I hope you have understood this problem. So from time to time, I have brought you the real-time JEE Advanced questions which are very useful to you. Please subscribe my channel for not missing any of my video of such type and which are very useful.